Hello everyone, I am Balaji Rao. Welcome to BR Max class. We are almost at the end of this continuity chapter. In this class, what are the things we are going to learn? You observe this question number 21. What they are asking, discuss the continuity of the function. You observe this is of the form f of x plus g of x. This is of the form f of x minus g of h of x plus g of x, h of x minus g of x, h of x into g of x, this type of problem. And you observe this question number 34, last problem, and this question number 34, they are of one model. Okay, and you observe this question number 31, show that the function is continuous function. Actually it is composite function. We are going to discuss continuity of this composite function. 31, 32, 33 are of one model. So total two type of problems we are going to do in this class. Before going to start this video, please drop a like for this video. Without much delay, let's begin the class. You observe this question number 21. What they are asking? Discuss the continuity of following functions. To understand this, first you need to know this statement. You see this statement, this is the theorem we have. What is this theorem? If f and g are two real functions continuous at C, f and g are two continuous functions at C, then f plus g is continuous at C, f minus g is continuous at C, f into g is continuous at C, f by g is continuous at C. These 4 points we have. Okay. So 21st problem and 34th problem. To do these two problems, I am going to use this theorem. What is this theorem? If f and g are continuous functions, then f plus g is continuous. Okay. If f, g are continuous functions at x equal to c, then f minus g is continuous at x equal to c. F into g is continuous at x equal to c. F by g is continuous at x equal to c. Okay. So I am going to use this theorem. Right. Let's start the solution for this problem. Solution. What I'll do here, you observe this question. I am trying to prove that I am trying to discuss the continuity of this function sin x plus cos x. In last class, what you learned? In last class, you learned that all trigonometric functions are continuous functions. In last class, you learned that all trigonometric functions are continuous functions. Sin x, it is a continuous function. Cos x, it is a continuous function. So what I'll do here, first thing, they already given here f of x, na? So I'll take these functions as h of x, g of x. So let h of x equal to sin x. What do you know about sin x? Sin x is continuous. Sin x is continuous on its domain. What is the domain of sin x? All real numbers. This is what we discussed in last class with the help of graph. All trigonometric functions are continuous functions. So sin x is continuous on all real numbers. Okay. Now I'll take g of x. Okay. What is g of x? What is g of x? I'll take g of x as cos x. Okay. G of x is cos x. What do you know about cos x? What do you know about cos x? Cos x is continuous on its domain. What is the domain of cos x function? Is all real numbers. What the point is, you know that all trigonometric functions are continuous functions and sin x is continuous. What is the domain of sin x? All real numbers. Cos x is continuous function. What is the domain of cos x? Is all real numbers. Okay. We know one point from that theorem. What is that point? We know that if h of x comma g of x are continuous on R, from this, what is the domain of h of x plus g of x? Look here, h of x, 1 minute here, let me explain. Functions knowledge little bit needed here. H of x is a function whose domain is d1. G of x is a function whose domain is d2. Suppose, what is the domain of h of x plus g of x? The domain of h of x plus g of x is d1 intersection d2. What is the domain of h of x minus g of x? Its domain is D1 intersection D2. Its domain also D1 intersection D2. And what is the domain of h of x into g of x? Its domain also D1 intersection D2. So what I am trying to say here, h of x is continuous on R, g of x is continuous on R. What is the domain of h of x plus g of x? What is the domain of h of x plus g of x? R intersection R. Real numbers intersection real numbers is what? Is a real number only. Okay. So what I'll write here, that implies h of x plus g of x. h of x plus g of x. What is h of x plus g of x? h of x is sin x, g of x is cos x. h of x plus g of x is sin x plus cos x. Sin x plus cos x is continuous on all real numbers, because this is what we learned from the theorem. If h of x, g of x are continuous on R, then h of x plus g of x is continuous on R. So here what they are asking in the question, f of x is sin x plus cos x. Sin x plus cos x is continuous on R? Yes, it is continuous on R. So sin x plus cos x is what? That is f of x. That implies f of x, that means given function, is continuous. f of x is continuous on real numbers. I hope you understand this. Now, actually what happened? I completed a bit. Okay. Now I am going to do the next bit. What is the next bit? We need to discuss continuity of sin x minus cos x. This is very similar to first bit. Okay. How to write its solution? Okay. Right. We are discussing about second bit. First thing, you observe here, what are the points we need to know here? Here what we are discussing? We are discussing that sin x minus cos x is continuous or not. For this, what I taken? First I taken sin x. Look here, I taken sin x as h of x, cos x as g of x. Okay. From last class, what you know? You know that sin x is continuous function on all real numbers on its domain. Domain is sin x domain is all real numbers. Cos x domain is all real numbers. We know this point from the last class. All trigonometric functions are continuous function. So sin x is continuous function, cos x also continuous function. We know that from theorem, h of x, g of x are continuous on real numbers, then h of x minus g of x. h of x minus g of x means h of x is sin x, g of x is cos x. Sin x minus cos x is continuous on R. What is in the second bit? Sin x minus cos x is given as f of x. You observe here in the second bit, sin x minus cos x is given as f of x. So I got that f of x is continuous on R. I hope you are understanding. Now we'll move to third bit. What is third bit? Third bit also very similar to the second bit. We are doing third bit, bit number C. What is this third bit? Look here, what they are asking in third bit, f of x equal to sin x into cos x. We know that if f of x, g of x are continuous at C, then f of x into g of x is continuous at C. This is what we learned from the theorem. Okay, so same like this only. First I will take h of x as a sin x. First I will take h of x as sin x. 1 minute here. Okay, look here. And we know that sin x is continuous on its domain. And we know that cos x is continuous on its domain. And what we want here? We know that if h of x comma g of x are continuous on R, from the theorem, what you know? We know that h of x into g of x. h of x into g of x, that is sin x into cos x. Sin x into cos x is continuous on all real numbers. Okay, so in this third bit, sin x into cos x is given as f of x. You observe here in this third bit, what is sin x into cos x? They given it as f of x. So what you got here? This is continuous on all real numbers. These are very easy bits. Look here. What is the question? Actually, this is the question. Discuss the continuity of the following functions. What point here? What you need to know to do this problem? If f of x, g of x are continuous functions at x equal to c, then f of x plus g of x, f of x minus g of x, f of x into g of x are continuous in its domain. Okay, so 21st problem is over. Now directly we will move to 34th problem first. You observe here, if I know that mod x is continuous, if I can prove that mod x is continuous, and if I can prove that modulus of x plus 1 is continuous, by using that theorem, if f of x, g of x are continuous functions, then f of x minus g of x is continuous. From that, I can easily prove this result, this problem. Okay, so let's start the solution for this question number 34. See, different methods are there to check the continuity. Here I am using graph method. In regular method also you can do, but I felt that in graph method students can understand this very easily. First, what about modulus function? Modulus function graph is standard function graph. In class 11 max you learned the graph of modulus function. Modulus function graph, how it will be? It will be victory symbol, correct? Victory symbol. I will draw that. So first thing, let h of x equal to mod x. Okay, what is the domain of mod x? Domain of h of x. Domain of h of x. Domain of modulus function is all real numbers. Okay, now what I'll do, I'll draw the graph of this modulus function. Modulus function graph, you know, it will be victory symbol. Modulus function graph will come like this. You observe the graph of modulus function. I'll write here, I'll name this function here h of x equal to mod x. H of x equal to mod x. Okay, you observe this graph. In this graph, any gap is there? There is no gap in its graph. So modulus function is continuous function. We can easily say this modulus function is continuous function. Okay, so from the graph, that implies what I can write? From the graph of mod x, what we can say? We can say that h of x, what is h of x? Is mod x is continuous. Okay, we came to know that it is continuous. Very good. Now I taken this, I drawn its graph, I got that there is no gap in its graph, so I can say that it is continuous, and it is continuous on real numbers. Now I'll draw the graph of modulus of x plus 1. Actually this is not standard graph, but with the help of graphical transformation you can easily draw the graph of modulus of x plus 1. I'll tell you how to draw that graph. Now what I'll do, I'll take g of x. G of x is modulus of x plus 1. Okay, now I want to draw the graph of this one, modulus of x plus 1. Okay, modulus of x plus 1, mod x looks similar, but little bit of difference is there. What is that little bit of difference? Okay, first minus 1, suppose this is minus 1, 0, plus 1, and modulus of x plus 1 graph will be like this. See here, when you put x equal to minus 1 in this, g of x will be 0. Put x equal to minus 1 here, put x equal to minus 1, minus 1 plus 1 is 0. So mod x and modulus of x plus 1 graph will be like this. You can easily draw its graph. This is what g of x. G of x is what? Modulus of x plus 1. Okay, now you observe the graph of modulus of x plus 1. You observe domain is all real numbers. For this function, domain is all real numbers. Is there any gap in its graph? There is no gap in its graph. So I can say that this is continuous. So I'll write here domain of h of x. You know what is the domain, how to calculate domain in functions chapter you learn. It is easy to memorize. Domain of g of x. Domain of g of x is what? All real number. How you can say domain of this is all real numbers? You take any real number, g of x is defined. You take any real number x, g of x is defined. So from the graph of modulus of x plus 1, I'll write here, from the graph of modulus of x plus 1, we can say that, what we can say? We can say that g of x is, what is g of x? Modulus of x plus 1 is continuous. I hope you understand. So what the point? You got that mod x is continuous function. Mod x is continuous function. You got that mod x is continuous, and you got that modulus of x plus 1 is also continuous. We know that if f of x, g of x are continuous functions, then f of x minus g of x is continuous, right? If f of x, g of x are continuous functions, then f of x minus g of x is continuous. So we will write that this implies h of x minus g of x. Here the point is h of x is continuous on real numbers, g of x is continuous on real numbers. What is the domain of h of x minus g of x? Domain of h of x minus g of x is intersection of this set and this set. Domain of this one is all real numbers. H of x is continuous on real numbers, g of x is continuous on real numbers. from the theorem we can say that h of x minus g of x is continuous on real numbers. So what is here h of x minus g of x? H of x minus g of x is here mod x minus modulus of x plus 1 is continuous. What they are asking in the question? Find all points of discontinuity. You observe here, find all points of discontinuity, but here there is no point of discontinuity. This function is continuous function. There is no point of discontinuity. I hope you understand this. Now another 3 problems are there. You observe this question number 31. I hope you understand last 2 problems. Now you observe question number 31. Like theorem 1, we have another theorem. If f of x, g of x are continuous functions, f circle g, g circle f also continuous on its domain. What I am saying? If f comma g are 2 continuous functions, then f circle g, g circle f are also continuous functions. I am going to use this concept to do coming 3 problems. F of x, g of x are continuous functions, then f circle g, g circle f also continuous functions. Here important thing is you observe this cos of x square. It is a composite function, cos of x square. In these 2 functions are there. One is cos x, another one is x square. Okay, you observe in these 2 functions are there. One is trigonometric function, another one is polynomial function. Okay, observe the solution. Let h of x equal to, here first I'll take trigonometric function. Okay, you can take h of x as x square also. In these 2 functions are there. I identified one is trigonometric functions. I'll take h of x as cos x. Cos x is continuous function that we learned in last class. All trigonometric functions are continuous functions. So h of x, I taken it as cos x. We know that cos x is continuous function. Okay, now g of x. What is g of x? Here 2 functions are there. Now one is cos x, another one is x square. Now I'll take g of x as x square. Okay, x square. What do you know about x square? It is a continuous function. In theory part, we learned that every polynomial function is continuous function. Every polynomial function is continuous function. So here x square is a polynomial function. It is continuous. This is continuous. Okay. This is continuous. Okay. Now what you know? Here what you got, h of x is continuous, g of x is continuous. You know that h circle g is continuous, g circle h also continuous. Now you need to check h circle g, g circle h. You need to check both. Which one gives you? Suppose h circle g gives you this one, then we will take h circle g. Okay, what I'll do here, I'll calculate h circle g as well as g circle h. First, I'll calculate h circle g. Okay, h circle g of x. H circle g of x is what? H of g of x. Okay, h of g of x, that equal to h of, what is g of x? Look here, what is g of x? Here g of x is there na? Here h of g of x. Here g of x is there na? What is g of x? G of x is x square. So in place of g of x, I'll write x square here. Okay, x square. Right. Now what I need? H of x square. H of x square. What is h of x? H of x is cos x. What is h of y? H of y is cos y. What is h of z? H of z is cos z. What is h of x square? H of x square is cos of x square. So h of x square is cos of x square. For what function we are looking? We got the same function or not? We got it. In case if you didn't get, then we will calculate g circle h. Here luckily h circle g of x is cos of x square only. I hope you are understanding, right? So h circle g of x is cos of x square. Okay. So what I am trying to say here, h of x is continuous, g of x is continuous, then we know that h circle g is continuous. So h circle g of x is continuous. H of x is continuous, g of x is continuous. That's why we are saying that h circle g is continuous. So therefore h circle g of x, what is that? That is cos of x square is continuous function, is continuous. I hope you understand this. Now we will move to next problem. You understand last problem? You observe, show that the function is like this, modulus of cos x is a continuous function. Again, Modulus of cos x is a composite function. In these two functions are there. One is modulus function, another one is trigonometric functions, that is cos x. Okay, let's start the solution. First, let h of x. What I'll do, I'll take h of x as a mod x. Modulus function is there now. You know that from the graph of modulus function in this earlier problem we discussed, modulus function is continuous function or not? Yes. If we observe the graph of modulus function, it is continuous. Okay, it is continuous. And what about g of x? If you observe this, in these two things are there. One is mod x, another one is cos x. What do you know about cos x? We know that all trigonometric functions are continuous. So obviously cos x is also continuous function. After taking h of x, g of x, you calculate h circle g, g circle h. Which one will gives you modulus of cos x, that we will consider. For example, in this problem, first I will calculate h circle g of x. Okay, h circle g of x. From the definition of composite function, in place of this circle we can write the bracket h of g of x. Okay. Now look here, g of x is there. What is g of x? G of x is cos x. So in place of g of x, I'll write cos x. Okay, that equal to h of. What is g of x? G of x is cos x. I hope you understand this. Okay, now I need to calculate h of cos x. What is h of x? H of x is mod x. H of y is mod y. H of z is mod z. H of apple is mod apple. Just joking. H of cos x is what? H of cos x is mod cos x. Correct? So here h of cos x is what? H of cos x is modulus of cos x. Luckily we got very easily for these two. Okay. Look here. We are looking for mod of cos x only. We got it. So what you know here? H of x is continuous. G of x is continuous. So from the theorem we know that h circle g is also continuous. What is h circle g here? Modulus of cos x. That implies h circle g of x. What is h circle g of x? That is modulus of cos x is continuous. I hope you understand. Okay. You observe this one. Examine the sine of mod x is continuous function. Sine of mod x. Okay. You observe the sine of mod x. In this also sine of mod x, two things are there. One is trigonometric function, another one is modulus function. So I'll start. Let h of x equal to, you take h of x as sine x. Okay. It's your choice. You can take h of x as mod x also. What do you know about sine x? Sine x is trigonometric functions. All trigonometric functions are continuous functions. Sine x is continuous. Okay. Sine x is continuous function. What about g of x? As I observed, given function, in these two things are there. One is sine x, another one is mod x. So sine x already taken, another one is mod x. Okay, mod x. What do you know about mod x? From the graph of modulus function, we can easily say that modulus function is continuous function. So mod x is continuous. Okay, mod x is continuous. Good. Now I need sine of mod x. To get sine of mod x, I will calculate h circle g of x, g circle h of x. Which one will gives you sine of mod x? That I'll take. Okay. First I'll calculate h circle g of x. Okay. H circle g of x. That is h of g of x. Good. H of, what is g of x? Here g of x is there. Now what is g of x? G of x is mod x. Okay. G of x is mod x. That equal to, okay, h of mod x. We need to calculate h of mod x. What is h of x? H of x is sin x. What is h of y? H of y is sin y. What is h of z? H of z is sin z. What is h of mod x? H of mod x is sin mod x. Correct? H of mod x is sin mod x. Luckily we got this time all directly. All we got for h circle g of x only. It's okay. In case h circle g of x you got it as mod sin x, then we will calculate g circle h of x. Okay. Now h of x is continuous, g of x is continuous. So what you know from the theorem? You know that h circle g of x is continuous. So I'll write that. Therefore h circle g of x. H circle g of x is what is h circle g of x? That is a sine of mod x is continuous. Continuous. They are asking examine the continuity of this function, and I came to know that it is continuous function. I hope you understand these problems, right? Today we done two types of problems. I hope you understand all those problems. With this, this continuity part is almost over. One or two problems are remaining. They are easy problems. You can try your own. But some theorems are there, like every polynomial function is continuous function. That type of theorems. If any one or two problems are needed, then in next class also what are the remaining things are there, I'll do, and with that I'll complete this continuity concept.